Okay, let's take a look at lesson 70. This is page number 423 in your math book, and we're talking about volume. We have studied perimeter first, that's the distance around an object. We have studied area, that's how many square objects could fit the floor. Think of it like someone tiling a floor in the kitchen. The square area is how many 1 foot by 1 foot tiles we take to cover the floor. Now we're working on volume. Perimeter is the distance around the room. Area is how many square tiles you could fit on the floor, and volume is how many boxes, 1 foot by 1 foot by 1 foot, think of a square box, would it take to fill the room from floor to ceiling, wall to wall. Okay, so that's volume. It's three-dimensional. Okay, there's a length, there's a width, but there's also a height. Okay, and they're going to ask sometimes how many 1 centimeter cubes, in example number 2, can be placed inside this rectangular box. So my formula for volume equals area of the base times the height. Area of the base times the height. So I first look at it like an area problem. I solve that area problem and I times by how tall it is, and then I'm done. Remember, area, if we were solving in centimeters, will be centimeters squared because it's two-dimensional, a length and a width. Volume is length times width times height, is three-dimensional. So if I was solving for centimeters for volume, I always put my answer as cubed. Okay? Let's take a look at example number 2 on page 424. Okay? So I have a box, and I drew it kind of confusing because that's how they roll. Okay? And something like this. They have 3 centimeters out here. They have 5 centimeters. And they have 4 centimeters. Okay? So I'm going to look at the base of the object, which is right here. If I took this base and flipped it up, it'd look like this. I was looking just at the bottom of this. I flipped it up. It would be 5 centimeters by 4 centimeters. That's the base of that object. So it's 5 times 4, which is 20. The base is 20. Area of the base for volume times the height. How tall is it? Well, it's 3 centimeters tall. So once I find out the area of the base, I times by the height. 3 times 20, of course, is 60. And my dimensions are centimeters, so it's centimeters cubed. Okay? Let's try example number 3. Example number 3 is even easier because it's a square. When it's a square, all the sides are the same. Okay? Well, Brian, what do you mean? Oh, great question. Okay? It's 4 by 4 by 4. So the really simple way to do it is just do 4 times 4 times 4. Because 4 times 4 is 16, and you already have the height because this one's 4, and this one's 4, and this one's 4. All the angles are all 4. So 4 times 4 is 16, times 4, I want to say is 64. Yeah, 64. Okay? You could also, to cheat on this one, you could just do 4 times 5 times 3. 4 times 5 is 20, times 3 is 60. Okay? Length times width times height. Okay? Let's go ahead and take a look at practice A. Practice A on page 424. I want you to read it, and I want you to try to solve. Remember, volume is area of the base times the height. You actually have to use your tiny little finger and do some counting. Okay? So try practice A. Pause the video, and then we'll solve it together. Okay, let's read it. Practice A. This rectangular prism was constructed of sugar cubes. I don't know why. Its volume is how many sugar cubes? Well, I gotta get my chubby little finger. I'm gonna count the sugar cubes on the bottom. 1, 2, 3, 4, 5, 6 sugar cubes on the bottom facing me. If I peek around the corner, I can count 3 sugar cubes back. So if I was going to draw this figure, something like that, which is terrible, I would know that this is 6 and this is 3. Now how tall is it? Let's measure the height. 1, 2, 3, 4. It is 4 high. Okay? So 6 times 3 is 18. And then 4 times 18, I did not memorize, is 72. So you don't need to say 72 sugar cubes high, okay? Or 72 sugar cubes cubed, because they already said sugar cubes. They're asking how many sugar cubes are there in all. So once you've done length times width times height, your answer is just 72, okay? Look at letter B. Why don't you try to solve B, pause the video, and then we'll do it on the board. Okay, let's take a look at letter B. This one's pretty simple. Find the number of 1 centimeter cubes that can be placed inside of a box with dimensions as illustrated. Alright, so my dimensions, it's a box. A nice, simple box. And it's 10 by 10 by 10. 10 times 10 is 100, times 10 is, you guessed it, 1,000. And so when they said how many 1 centimeter cubes, they expressed it as 1,000 1 centimeter cubes. If you said 1,000 centimeters cubed, that's fine. Sometimes they ask the questions a little strange. They're asking how many objects, and sometimes they're going to say, put the answer cubed. It's going to be different every time. Let's try one more, letter C. Letter C. Go ahead and try it, pause the video, and then we'll review it. Okay, letter C. What's the volume of this rectangular prism? Dimensions are in feet. I don't really want to draw it. I think you've already got it down by now. If the base is 10, the width is 10, the length is 4. 10 times 4 is 40 times 6 high. Length times width times height is 10 times 4 times 6. And that's going to be 240. Now they say dimensions are in feet. Dimensions are in feet. It's supposed to be feet what? No, you guys say it out loud. Feet what? Good job. Feet cubed. Except for some of you didn't answer, and I know who you are. Okay? 240 feet cubed. All right, pretty simple. And that's problem set, lesson 70, which starts on page 225. Okay?